Hey, Algebra 1. Today's notes are in the next topic, which is Lesson 18, Day 1, which is simplifying exponents and eventually writing the rules for exponential functions. This carries over from the conversation in the previous lesson about how you can transform a function and how we were talking about exponential functions and what they particularly look like. I've got Desmos ready to go because we might do some graphing along the way, but this first lesson is about exponent rules and reminding you some of the things that you should know or remember about how exponents, the properties of exponents. There are a couple of different topics that you need to know as a result of this. So let's just dive right into what should be a review, I'm anticipating. And let's start with how we have x to the negative 2 power times x to the negative third. I know it's a times because even though there's no decimal right here, there's no plus sign, minus sign, or division sign either. So we just assume that that's a times. And then the fact that it's to the power of 4, we could think about that as writing x to the 1/2 and x to the negative 3 4 times. And I don't want to fill in the blank because that's a lot of space to fill in the blank. But the idea is this is copied 4 times. That would mean that we have this x to the negative 2 once, twice, 3, 4 times, and x to the negative 3 the same number of times as well. Well, multiplying all of that out or combining all of that out would be the same as the shortcut of, first of all, do it's in parentheses. So negative 2, negative 3, we add the exponents. Keep the fact that it's still to the power of 4, and you multiply these two numbers together. Why that is because we expanded all the way out. So here we have x to the negative 20. It's not technically proper to have a negative exponent, or we certainly would at least like you to be able to express this as an expression with a positive exponent. So when you have a negative exponent, it flips the expression over the fraction bar. Okay, number 2. Here we have x to the 4th power, and that quantity is raised to the negative 3 power. So remember we just did in the previous problem, those two things, we're going to multiply the exponents, giving us x to the negative 12th. And so that quantity is remaining. We're going to continue to multiply by 2x to the 4th. So the 2 as the coefficient can move to the front. And then the x to the negative 12th and the x to the 4th, because they're on the same row, we are going to add the exponents. This is multiplying exponent rules. So 2 moves to the front, and x to the negative 12th times x to the 4th adds to make x to the negative 8th. Again, avoiding negative exponents, this would be the same as 2 on top and x to the 8 on the bottom. And I have to write it like this because I want you to understand this stays on the top. It does not go to the bottom. This 2 has an exponent that's positive. It's technically positive 1. And so it's different, or the rules will not apply to it from the negative 8. Okay, let's keep going. How about this? I'm going to say that you need to do 3 and 4 as extra practice. And let's do 5 together. Okay, so with number 5, maybe adjust. Good enough. Okay, here we have number 5. Number 5 has 2x squared y to the 4th, 4x squared y to the 4th, and 3x. We should first of all combine all coefficients. And I'm going to cleverly combine, where I'm going to recognize that if 3 is on top and 3 is on the bottom, I'm canceling that out first. So that means I'm left with 2 times 4. Then I have to look at all the, and they're on top of the fraction. Okay, then I have to look at all of the x's that are similar. And there's a multiply everywhere there's a multiply. So this is technically x squared times x to the 1st. And when you're multiplying exponents, or you're multiplying things that have the same base, you add the exponents. So x to the 2, 2, 1, x to the 5th. Then we're going to do the same thing with the y values. So there's y to the 4th and y to the 4th, and they're technically under multiplication. I mean, I can cleverly switch these around to make them be next to each other. So therefore we have 8x to the 5th times y to the 4 plus 4, y to the 8th. That's the top. On the bottom of the fraction, we have x to the negative 3 and y squared. So we're not technically done. This is step 1. Step 2 is to recognize that because those x's are the same and their exponents are different, we use a different exponent rule. We subtract, which means we're going to have 5 subtracted by negative 3. Those are the exponents, 5 and negative 3. And so when we subtract them, we wind up writing a subtraction of a negative, and that is the same as a positive. So this really becomes 8x to the 8th power. Last of all, since there's y to the 8th and y squared, the 8 and the 2 follow the pattern. They subtract, and so we're left with 8 minus 2. That becomes the exponent y to the 6th. This is a simplified answer for number 5. Please give number 6 a try. That's called number 6 extra practice. And that will be the entry task for lesson 18, day 1. Okay. You can go ahead and skip ahead a few seconds. I'm going to go and get this video queued up or get the page queued up so that we can see the rest of the lesson. Okay. And bring it back. Did you know that there are other roots beyond simple square roots? And what do you do when your calculator doesn't show you for example, a cube root option or a fourth root, etc.? There are other roots besides just a square root or a cube root. So the square root of 9, let's just think about the concept. The square root of 9 is 3 and also negative 3, because 3 squared is 9, and so is negative 3 quantity squared. Those two things both equal 9, so therefore if we're asked to find the square root of 9, it's both positive and negative, because when you square them, you get that number 9 answer back. The cube root of 8 is 2, and only 2, because 2 to the 3rd power is 2 times 2 times 2, which equals 8. So therefore we can write this as the cube root of 8. We see that that equals 2. The square root of some number n is a value that when multiplied by itself, which is same thing as squared, produces the given number n. In other words, r will be the square root of n, so r equals square root of n, if r squared, which equals r times r, equals n. This is where we start to talk about maybe a higher level mathematical idea, that you have this if this, or this is true if this is your answer. We run into problems if r is, if negative. How can you have a square root that produces a negative answer? Okay, or I'm sorry, n, if n is negative. All right, moving on. Now we're going to talk about the concept of other things. Let's go, let's make sure that the rules, the properties of exponents are clear. All right, so here we go. If you're going to multiply exponents with the same base, so that is, if you multiply exponents with the same base, you add the exponents. The example would be x squared times x cubed is x to the power of 2 plus 3, and that is x to the 5th. If you have the scenario of divide exponents with the same base, then we can subtract the exponents. So subtracting the exponents would be an example something like this, like x to the 5th divided by x squared. We would do x to the 5 minus 2. 5 minus 2 is 3. Last of all, if you're going to take a power of a power, you multiply the exponents. That's true because let's say we have x squared and we are raising it to the 4th power. We would be technically writing this thing in the parentheses 4 times, and then the square means we're going to write the x 2 times each. So we really have 1, 2, 3, 4, 5, 6, 7, 8, 2 times 4 x's in our expression. These rules apply for using fractional exponents. All my examples used integers, but we can also say the same thing is true with 1/2 exponents. So like if you have x to the 1/2 times x to the 1/2, that would be x to the 1/2 plus 1/2, which is x to the 1. Well, hold on a second, okay? If you have the square root of x and another square root of x, that's the same as saying that the square root of x is itself squared. And I hope it's clear by now that x is the result of squaring a square root. So this thing equals x, and this thing equals x. We're going to finish this statement out. We're going to say it this way. X to the 1/2 is the same as square root x. In fact, we can go even further and say that x to the 1/n, so some sort of fractional exponent 1/n, is the same as, yes it is, it's called the nth root of x. So whatever fraction you have, we can rewrite it as a radical, where n is the exponent like looking thing of the radical, but it's the nth root. Okay, knowing that, let's try some examples out. Here we have the 9th root of b to the 4th. So the quantity inside, called the radicand, b to the 4th. We're going to take that expression and we're going to raise it to the power, since the 9 is out here in front of the radical, it's going to be the 9th root, as in to the 1/9 power. And if you have a power, remember the rule, if you have a power of a power, you're going to multiply the exponents. So we're going to rewrite this as b to the power of 4 times 1/9. Put that over 1, multiply straight across, b equals 4/9. I kind of wrote into this extra space, so just deal with it. Let's do a good old extra practice for letter B, and then I'll talk to you about letter C right now. In letter C, 2 square root x times 4 x to the -5/2. The first thing would be to rewrite this with the 1/2 exponent. This property is going to show up like all the way until calculus, that you should never, or you should avoid using radical signs and stick with the 1/2 exponent property. It actually works out a lot better for us. X to the 1/2 times 4 x to the -5/2. Well, we can put those together through multiplication to make 8. And then this gives us x to the 1/2 times x to the -5/2. And from this property, when you are multiplying, you need to add the exponents. So x to the 1/2 plus -5/2. Adding a negative is the same as subtracting. So 1/2 minus 5/2 gives us, let's put some equal signs in here, 8 times x to the -2. Check it out for yourself in the calculator if you want, or at least reason through your fractions. A half take away 2.5 is -2. It'd be best if we didn't have a negative exponent, although this is fine. But it'd be best if we didn't have a negative exponent. So the 8 stays on top because it has a positive 1 exponent, and the x squared goes to the bottom, and there's our answer. All right, I love number 3, example 3, because example 3 is blending a lot of different things together. In fact, the properties of exponents can be used to rewrite and simplify expressions. So in this problem, we have 2 to the 3 times t. So I'm gonna show that a little larger. 3 times t. And if you can recognize, if you can recognize that this is a multiplication, then you're talking about being in this statement, and you can backpedal. Or it's like we're living over here, and I want you to work your way backwards to this to maybe get a different expression. That really means that the fact that we're multiplying in the powers level is so that we can rewrite this as 2 to the 3rd to the power of t. We would rewrite this as multiply if we wanted to, but this is another way to rewrite it. You should be able to know what 2 to the 3rd is. 2 times 2 times 2. Doesn't that make 8? It's actually true then that this expression, 2 to the power of 3t, is able to be cleverly uncombined, to be recombined to make our answer, I'll just write it out there, box it, 8 to the power of t. Okay, I'm gonna start with letter B, and then you're gonna finish it. So this is partly an extra practice. 5. Now remember what we're doing. We have, I'll write it larger, but then I'm going to talk about splitting it. When you are adding terms together, we can use the fact that adding exponents is the same as, well, uncombining, so their bases are being multiplied, meaning 5, 4x times 5, 2. If this was the problem, you would add the exponents to simplify, but I'm telling you do that in reverse. So we should rewrite. And then, because there is the same scenario, but now used here, we should cleverly uncombine, and I'll leave you some math to do. We should cleverly uncombine 5 to the power of 4x so that we just have 5 to the 4th power raised to the x power. And then it's up to you. Your job is to cleverly simplify and combine this. So I'm asking you for extra practice to full simplify. Okay, I'm going to continue. There are 2 more pages. Okay. Use the properties of exponents to rewrite the expression and achieve an exact answer to the square root expression. So this one is a great concept that's useful in the realm of geometry, but we bring it back now because of its connectedness to expressions and exponents. The 27, you need to think through your list, what numbers could 27 factor into? And it turns out it could factor into 3 times 9. Now I'm thinking that it could factor into something else, so I'm going to show a second path. It could factor into 3 times 3 times 3. 3 times 3 times, yep, there we go. And all of those are square rooted. But the reason why I want to focus on what's up here is because you can split a product of exponents. Remember, these are exponents. So we could write this as 3 times 9 to the 1/2 power. And because we can write that as 3 times 9 to the 1/2 power, we can split this into 2 pieces. 3 to the 1/2 times 9 to the 1/2. Now you might be thinking, like, LeBrant, why would we do that? And it's because there are more complicated questions coming up. But think about this one. If you're good with that, going back to looking like this, and you're good with 9 to the 1/2 power going back to look like this, we can rewrite the exponents in a more palatable form of square roots. So the square root of 9 is 3, and the square root of 3 is also 3. This is a simplified, considered the exact answer of 27. Or if you'd like, we could look at how you took the 27 and you broke it all the way down. We call this one prime factorization. It just is a more lengthy process, but it also works. And I just want to show it to you. The fact that 27 is 3 times 3 times 3 means that we can write 27 under the radical sign as 3 times 3 times 3, so that we can therefore then split. We can go square root 3, square root 3, square root 3. And with cleverly combining, these 2 things are being multiplied together. So I guess technically these 2 things can become root 3 squared. This other one doesn't have a home, so I'm just going to bring it down. And if you remember your mathematics about squaring a square root, they cancel out, and so we're again left with 3 root 3. Either method A or method B, they both take you to the same answer. I'm going to mark E as extra practice and say that after we, I'm sorry, D. We're going to mark D as extra practice and say after we do E, you need to go back and do that one. I figure because it probably makes this one a little bit easier to do. Here we go. 54, it's not a perfect square number, but neither is 27. So if we look at 54 and think about how we can split it, we can split it into, let's think about the biggest perfect square number that divides 54. I think 9 does. So 9 times 6. Then I'm going to take x to the 6th, and I'm going to cut it in half to make x to the 3rd times x to the 3rd. Then I'm going to take y to the 8th. I'm going to cut y to the 8th in half. You might be saying, why, LeBrant? This seems dumb. Well, that's your fault. So square root everything. Now the trick with this one is that 9 times 6, that's still 54. No laws are broken. X to the 3rd times x to the 3rd is x to the 6th. No laws are broken. Y to the 4th times y to the 4th is y to the 8th. And then we can cleverly split and group and combine. I can put square root 9 times square root 6 times square root x to the 3rd times square root x to the 3rd times square root y to the 4th times square root y to the 4th. And thinking about it, square root 9, well, that's just 3. Square root 6 doesn't have a nice answer, so leave it. if I notice that I have 2 of these, and that's technically the same as one of them squared, then the square and the square root cancel. So I'm left with x to the third. The same thing happens here again. Square root of y to the fourth times square root of y to the fourth. Well, I can rewrite this as the square root of y to the fourth squared, and a square root cancel, so I'm left with y to the fourth. Whiz bang boom, there's our answer. We have split this to make 9 times 6, square root it. Split the x to the sixth into halves, so when you do that, keep one of the halves. And y to the eighth splits into y to the fourth times y to the fourth because of adding exponents. So we have y to the fourth, and then that's actually being squared, so it's getting split. But yes, we get our answer right here, 3 root 6 times x to the third y to the fourth. Okay, turn the page. Long video, I know. There's a lot of stuff to do. You got a lot of practice to get in there. Question 1. Simplify the following expression. Leave your answer in the form a to the power of b. So, if you have 7 to the power of 5, and that expression is multiplied by 3, 7 to the power of 5 to the power of 3, I'm going to write the whole thing out, means that this, you're going to multiply the exponents. And the 7 to the power of 6 just kind of hangs out. It's not really doing anything. So we can simplify the mathematics. 5 times 3 makes 7 to the 15th times 7 to the 6th. I'll leave you with one more. What goes in the box? If you're left with 7 to the 15th times 7 to the 6th, what does that equal? Write that up there. Number 2 is a couple of different paths. We could simplify inside, follow order of operations, or we could simplify outside because exponents can be attributed to both terms. Or we can just recognize that this is x to the 7th over x squared, and we are raising that expression to the third power. The thing about that is that if you have x's on top and bottom, they get to cross off. So we're left with x times x times x times x times x. That would be x to the 5th to the power of 3. And we've already addressed what math that is. Okay, I'm going to leave number 3 for you because we talked about it in another fashion, and it is difficult. But do you know what happens when you have things raised to the 0 power? What does that tell you? That's a major hint. I'll leave you with that major hint. I'll say this is extra practice. Please do it. Question 4. I'll do 4. You need to do 5. 5. Extra practice. A factory spends $9 to the 7th on salary every month. Sounds like a lot. There are 9 to the 4th workers in the factory. That also sounds like a lot. So how much does the worker earn on average in the factory each month? Leave your answer in the form a to the b power. Well, if the factory spends $9 to the 7th on salary, and they're going to split it 9 to the 4th power ways, then we can use properties of exponents, specifically subtract exponents, to find our answer. 9 to the 7 minus $4, which equals 9 to the 3, 9 to the third dollars. Taking a stab at it. 9 to the third. This doesn't seem like a lot. This month needs to probably be adjusted, like a week. Maybe. Week. Okay. 9 to the third is 9 times 9 times 9. This is 81. 81 times 9 is... week would be nice. I'll put a question here. Fortnight. Okay. Every 2 weeks. You get a 2-week paycheck. So 81 times 9 is 729. All right, not a lot. Maybe this should be what you earn a week. But the point is, this is how we would do the mathematics to answer the question. We would write out the total dollar amount, the total number of factory workers. We would subtract the exponents because of the design of the problem. And we're left with 9 to the third dollars per week. Let's stick with week. Per week. And it's per worker. Like every worker makes $729 a week. Okay, please do exercise 5. Yep. And I'm going to take a look at page 5. How are we doing? More of the same. All right, consider these expressions. The base of an exponential, let me get this slided in. The base of an exponential expression needs to be changed to match the requested exponential base. So big idea here is this is the change of base concept. So we could rewrite 8 squared. Well, 8 is 2 to the third. 2 to the third is 2 times 2 times 2. So that means 8 squared is 2 times 2 times 2 squared, or 2 times 2 times 2 times 2 times 2 times 2, 2 to the sixth. Because we can write all of these 2's all the way spread out, we can combine those 2 and those 2 and those 2, which makes 4 times 4 times 4. And that would happen to be 4 to the third. But if you're stuck, you're not sure what the answer actually is, just put everything together. 8 squared is 64. So it has an exponent of 1. And that's why those are the 3 different examples. 4 ways total, but 3 ways that are added to 8 squared to show you how you can achieve 64 as an answer, just by changing the base. I took the fact that there was the base, I rewrote it with some sort of exponent, some smaller term number. Let's do the same thing with 81. 81 is 9 times 9. So this is meant to be an exponent line, as in 9 squared. But if you can write this as 9 times 9, then you can split that into 3 times 3, 3 times 3. So the last thing is 3 times 3 times 3 times 3. There's a times there as well. Is to the 4th power. As in 81 is the same as 3 to the 4th. Okay, please do letter C. Which is bigger? And instead of before you just go to a calculator. No calculator just yet. You must first try to find a way to re-express this and then cleverly combine the exponents. And if you wind up with different numbers, you probably should say that they're not the same. You should find out which one is bigger. Okay, so in the practice, consider these expressions. The base of each exponential expression needs to be changed to match the requested exponential function's base. So here is a function. We've already more or less discussed it, but the point is that 2 to the third to the power of t means you have 8 to the power of t. Over here, one of the tricks that I'm using is that I can take the fact that both of these have an exponent of 4, and I can pull the 4 away. So then I have 52 over 13 to the power of 4. Now, if you remember, 52 cards in a deck, 13 suits of cards in each suit, or 13 cards in each suit. So 52 divided by 13 means that there are 4 suits, and it's still raised to the power of 4. This isn't quite base 2. A 4 is a number that can be rewritten as 2 squared. So 2 squared to the power of 4. If you see where I'm headed, I took this weird expression, simplified it so that it was some power of 4, and then power of 2, and then I rewrote it. And so now we can say we have 2 to the, what number goes there? All right, practice it. If you think you got it, you need the extra practice, do number 6. There are 2 options. This one actually should be written as a product of 2 exponential expressions. So you should take 36 to the first power and write it as 2 to the something times 3 to the something. It may be obvious right away, but I want you to think about the change of base idea. How do you split this so that you get your 2 and your 3 to pop out? Okay, that's page 5. Did you know that any number to the 0 power equals 1? 0 to the 0? I don't know. I think that equals 0. Or does it equal 1? I don't know. However, b to the 0, if b is not 0, we have at least that scenario. If b is not equal to 0, then that equals 1, and I want you to prove it. I would recommend that you prove it with something like this, subtract the exponents, but you could also prove it with some other methods. Okay, I'll let you think about that for a second. Rate yourself on the learning target and success criteria. Add the how can you improve. Don't forget that you need to do the problem set for homework, and you need to do the exit ticket. You know, while I'm here, let me do one. Enter an expression, asterisk. That's there because even though you're saying, like, what do you mean enter an expression? Like, there's no place to enter it. Well, that's just language from the SBA because it's meant to be like, hey, type in the box. right? So type in the box, aka enter an expression. Now it says equivalent to a to the 20th power, and it's in the form of a to the n times m. So we can think about different factors of 20. We can think about how 20 times 1, 10 times 2, 5 times 4, that's it. So take any factor pair. I'm going to pick this one because, yeah, I'm going to rewrite a to the 20th as a to the 5th power to the 4th power, meaning n is 5 and m is 4. Okay, you need to do the rest, but that's the big idea. How can you take the 20, maybe factor it or some sort of like cleverly separate it out, and then write it in another form that's been requested, like this form or this form or this form. Good luck. Having said that, problem set. All right, that concludes this video. I'll give you notes for day 2 tomorrow, and then your job is between after class to the next time class begins to have gone through the notes and added them to your packet. Thanks. Bye.